Today's lesson is 8.1, Defining Logarithms. A logarithm base b of a positive number x satisfies the following definition. For b greater than 0 and b not equal to 1, the log base b of x equals y if and only if b to the y power equals x. We read this as log base b of x. In other words, the logarithm y is the exponent to which b must be raised to get x. There is a common logarithm, which is a logarithm that has base 10. You can write a common logarithm like this, but we more simply see it written as simply log x without showing the base 10. The function y equals e to the x power has an inverse, the natural logarithmic function, which you would think would be y equals log e of x, but more normally we see y equals ln of x, the natural log. They put the L first so that we know we're talking about a logarithm. There is a formula to go back and forth between our logarithm and our exponential form, and here is the pattern to follow. I am going to use my colors to help me. So notice in the logarithm we have our base right here, and then in our exponent our base is here. We have our logarithmic base of this number, and that's going to be equal to our exponent. And then in here, we have the power of our exponent equal to our logarithm. So they just take different places in each one. All right, let's go ahead and rewrite a logarithm in exponential form. So here's our log base 3 of 27 equals 3. All they want you to do is take it from this form here and change it to this form here. That's all they want you to do. The arrow is double-sided because I could ask you to start here and then change it to this one, okay? So there's many ways that you could do this. You could start by writing log b a equals x, and then you could see that b is 3, a is 27, and x is 3, and then you could just go ahead and put them in this pattern. Okay, I'm going to use my colors, however, and I'm going to color my base 3. So what I'm doing is I'm looking at this one right here because they match, right? These two match. And I'm just going to color them, color code them accordingly. So this one would be orange like the A, and then the 3 would be purple like the X. Now what I can do is I can see that how my numbers go into this form, right? I know exactly where to put, what number to put here for B. I know exactly what number to put for X equals, and I know exactly what number to put for A because I did everything in the same color. So let me grab my pencil, and here we go. The base is going to be 3 for my exponent, for my exponential form. My exponent will also be 3 equals, and A is going to be 27. And that's it. It's just that easy. Okay? All right, let's go ahead and take a look at this example. Find the following logarithms. Now, the first thing that I'm going to do for these 3 logarithms is I'm going to go ahead and I'm going to set all of them equal to x. Then I'm going to come back and I'm going to color code them just like I did in the last example. So I'm going to grab my blue for all my bases. Now the second one and the third one, I can see the base. The first one, I can't see the base, but I have to remember what I saw on the last slide was that the common log does not have a base. It doesn't have to be written. We just all know that it's 10. So I'm going to add it in there. The numbers next to them I color orange. I'm just following my pattern from the last slide. And -8. And then all my x's, I'm going to make them purple. right? So what I know from the last slide is that I can change these into the exponential forms by taking their bases, which are the blues, raising them to the x's, which are the purples, which also happen to be x, and setting them equal to the base of, which would be the orange numbers. So I'm going to go ahead and do that. So it's blue raised to the purple equals the orange. Blue raised to the purple equals the orange. Now I'm going to go ahead and I'm going to grab my Desmos calculator, the scientific one that we've been using in class. Oh no, it went away. Oh, Mr. Palmer must be on his iPad. Shoot, I was going to try to do something really cool for you guys. Let me see if it'll let me now. No. Darn it. Okay, here we go. So for the first one, it was 10 to the x power equals 1,000. So I'm going to put in here 10, and I'm going to raise it to the power. Now, I can just start with 1. It's a whole number. It's not a fraction, so I know it has to be a positive number because that's how exponents work. So I could try 10 to the first power, but 10, any number to the power of 1 is just the number of the base. So let's go ahead and try 10 squared, 100. Let's try 10 to the third power. There we go. Now, if you were thinking, Miss, I really think that I could have just put this in the calculator, you're right. We could have just simply gone to the function. We could have pressed log, there it is right there, and then we could have gone back to the main and pressed 1,000 and take a look at that. We got our answer of 3. Okay, so let's go back to good notes and x equals 3. Okay, let me see if I can try my cool trick again. Now I can't. No. Ah, Mr. P, come on. No. Oh. Every time I try to grab it, it won't let me. Okay, we're just going to have to make it work, guys. Okay, 7 to the x power equals the fraction 1 over 49. Since my exponent is giving me a fraction for an answer, that means my exponent has to be negative. Let me try one more time. No. All right, let's go back in the way we have been. Let's go ahead and clear this. Clear all. 7 raised to, it has to be negative. Now I am going to go ahead and try -1. Remember, if you click the little circle, it's going to change into a fraction for you. Close. Let's try 7 raised to the -2. Decimal, change it into a fraction. There it is. So my answer is the -2 that I see over there by my cursor. All right, I'm going to try one last time. I don't think it's going to do it. Nope. Now, the last one, we have a base of 1/2 raised to a power, but this power is giving us a negative number. There is no solution for this one. There's no number that I can put into Desmos. We could try them all. That is going to give me a negative number when I raise a base to a power. That just doesn't happen. If my power is negative, I end up with a fraction like we see here. So if my power is negative, I end up with actually a fraction, and I'm never going to end up with a negative answer. So here my answer would be no solution. All right. I have one last example, but before we do that, we do need to talk about the change of base formula. In my change of base formula, I can take a log in this form, and if I do log base b of x over log base b of a, I can change them into being logs that I can put in my calculator or that I can use in another way, such that x, a, and b have to be greater than 0, and a and b, of course, cannot equal 1. I'm going to go ahead and color code this again, and I'm going to use some of the same colors that I used in the beginning. Now, I'm going to make my A be orange and my X be purple. And I'm going to make this base B, and I'm going to grab this smaller color because these are really small. There we go. And then I just want you to notice that you're going to take the X and put it on top, and you're going to put the A on the bottom. So notice where those numbers were, and then notice where they are when you do your change of base. Now, normally when we do the change of base, we want to use it so that we can use the calculator. Okay, like that's the whole goal of changing our base so that we can put it in the calculator and we can give an answer of a decimal. Okay, so here we go. Use your calculator to find the following logarithms. Round to the nearest hundredth. I really don't think it's going to let me, but I'm going to try one more time. No. Okay, so what I'm going to do is I'm going to go ahead and I'm going to put these in the calculator. Now, if I see an ln, I can put that right into the calculator. So A is going straight into the calculator because it's the natural log. If I see log with no base, I can put that right into the calculator. So A and B can go straight into my calculator, and then I can go ahead and round however they're asking me to round. The last one, though, because it's not a natural log and because it's not a log of base 10, it's not the common log, I have to use my change of base formula. So for this one, I'm going to have to use the change of base. We can go ahead and get it ready with our color before we move over there, just to help us out. So we're going to say that this is the orange and this is the purple. And then we'll have it all ready for when we have to do the change of base. All right, let's go ahead and put the first one in the calculator and the second one in the calculator. Okay, since Mr. Palmer's not cooperating with us today. Oh, wait a minute, now maybe it will. Yay, it's going to cooperate with us. There we go, you guys. I wanted to show you this. There we go. Now we can go ahead and we can see them in the calculator in the same time. So the first one, I'm going to go ahead and hit functions. And notice right over here above the E, there's my natural log. I'm going to go back to the main because that's going to give me back my keyboard with the numbers. And I'm going to just press 7 and there's my answer. Now I can come over here and I can go ahead and show you my decimal, 0.945991 dot 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 because it keeps going in the calculator. They want me to round to the nearest hundredth. They want me to round to the nearest hundredth. I don't know why it went gray on me. All right, so now I have to remember hundredth. How do I round to the nearest hundredth? So let's grab a color here. Oh, it doesn't matter. 100. Whenever my decimal is 100, remember that your decimal P part is right there. And that means that we need two numbers, 1, 2, after the decimal. So we're going to go ahead and find our decimal. Let me grab my pink back. There's my decimal. And I'm going to count 1, 2. There it is. This one here is going to help me to decide if I need to round it up, if I need to add one more, or if I need to let it rest. And all of this stuff doesn't matter. Okay, I didn't need to even look at them. I didn't even need to write them down. So there we go. I'm going to say 1.9, and I'm going to change the 4 to a 5 because the rule says 5 or more, add one more. All right, let's go ahead and clear this one, and let's put in the second one into the calculator. So once again, I'm going to press the function, and I'm going to press the log this time. I'm going to go back to the main, and I'm going to press 35, and there we go. So for the second one, I have 1.5 5. You know what? Let me see, guys. Hold on a second here. Let me put it down here. It's getting kind of crowded. 1.54406, blah, blah, blah. Let me grab that pink and let's count. Let's find our decimal. 1, 2. This one's going to tell me if I should round or not. I didn't need those, guys. 1.5. Should the 4 stay a 4, the underlined one, or should I add one more? Well, the 4 with the arrow on it says let it rest. So we're going to leave it just like that. Now, for the last one, I have to do a change of base on the last one. So what I'm going to do is I'm going to have to make sure that I rearrange them to look like this. So I'm going to take this and I'm going to make it be this. The log base that I'm going to use is going to be base 10. Oh, shoot, you guys, sorry. I need the log. Log. I'm going to make my base be the base 10. That way I can put it into the calculator, okay? Now, I don't need to write that base 10, but I wanted to do it for you guys so that you could see, based on the color and the change of base formula, what number I was putting there. I'm going to take and put the purple one on top. So that would be the 226. And I'm going to take the orange one and I'm going to put it on bottom. And that would be the 5. So that's how it looks when I change it. But what I'm going to put in my calculator is log of 226 divided by log of 5. That's what's going in the calculator over here. So I'm going to hit clear all. And I'm going to grab my fraction. I grabbed that from right underneath the wrench, the a over b. I'm going to go to my function. I'm going to put my log on the top. I'm going to go back to the main and I'm going to put 226 and I'm going to close. Oh, nope, it didn't do it. Hold on. 2, 6. There we go. Close it up. Go down to the bottom. Go back to your function, log, back to the main, 5. Close it up. There we go. So 3.367. That's enough because I need only decimal 1, 2. And this is the one that's going to tell me, and all these other numbers, they didn't matter anyways. And so my answer is going to be 3.37.